Welcome to section 9.3. This is actually a fresh video for 2020. Thanks to an alert student who's worked ahead. She contacted me. She found a couple of errors that I made, and I've confirmed that. So thanks much to her, and let's go ahead and get started here. Definition of a hyperbola. A hyperbola is a set of all points in a plane for which the absolute value of the difference of the distances from two distinct fixed points is called the foci. Just a whole lot of words right now, but the one word that's different here, if this was the definition of an ellipse, difference would be sum. So I like to say the difference between a hyperbola and ellipse is the difference. And here that is in action. We have distance 2, distance 1 from these fixed points, the foci. If we subtract those in either order, that's what the absolute value is. Or if we take the big one minus the small one, that's constant, which means here's another point right here. Let's call this distance 3. Let's call this distance 4. It means distance 2 minus distance 1 must be equal to distance 4 minus distance 3 wherever we go on that hyperbola. Transverse axis right here passes through the vertices and the foci. Definitely worth noting that the focus is farther away from the center than the vertex. There's our C as they show here. There's our A as they show there. So in an ellipse, when we had an ellipse, the value of C, the distance to the focus, was shorter than the value of A. And you might remember in an ellipse, we knew that A squared equals B squared plus C squared. And that's because A was the biggest, but A is no longer the biggest. And we'll come back, we'll talk about that. One of the things about ellipses that's nice is that the equations are very, very similar. The only difference is the difference. What used to be plus now becomes minus. Worth noting, A is not necessarily bigger than B. What is necessary is that, again, C, the distance to the focus here, is the biggest. It's bigger than A and B. And there is a Pythagorean relationship still, but this is a different relationship than when we had ellipses. In ellipses, it was A squared equals B squared plus C squared. Not a great memorize. Probably better just to realize, hey, the foci are farther away. The foci are the farthest away. So it's got to be C. If there is a Pythagorean relationship, it has to be C squared equals. The other thing I want you to note is down here, when the x is the positive term, the hyperbolas are opening in x direction, right, left. When the y is the positive term, we're opening in y directions, up and down. And of course, if we're at the origin, it almost goes without saying, this becomes x minus 0 squared, or just x squared. Y minus 0, y squared. And those are our most friendly to work with. Now, this I think is a really dangerous proposition to memorize. If you notice, it says when we have a horizontal transverse axis like this one, then the formula is this, and we go B on A. But when we have a vertical asymptote, the equation of the hyperbolas, and those are hyperbolas are looking like this. They're lines that kind of define the hyperbola. We'll talk more about that. When the transverse axis is vertical, then it's A on B. Otherwise, it's B on A. And I just think that's a dangerous thing. That would be an easy one to mix up. And good news is, this is going to make perfect sense to you if you follow along with me when we get to talking about the asymptotes. So let's take a look. Some things that might make sense if we think about it. If we have an x squared and a y squared term and just some random x and y and constant here, if A and C are equal, like 3x squared plus 3y squared, divide both sides by 3, I get x squared plus y squared. that implies that this thing is probably a circle. And I say probably because there are some interesting exceptions to that, which we'll be talking about. If A times C equals 0, if one of them is 0 but not both, which means we either have an x squared or we have a y squared term, but we don't have both, if that's the case, then we have a parabola. That should make sense. If A and C have the same sign, in other words, if they're both positive or both negative, understand, if they're both negative, we can multiply both sides by -1 and make them both positive. So if they're both positive or both negative, then we have an ellipse. But if they're different, if one's positive, one's negative, therefore they multiply to be less than 0. If A times C is less than 0, which just means one's positive, one's negative, then we have a hyperbola in almost all cases. There is some exception, but for the most part, you can take that one to the bank. Okay, first thing I notice on A as we go through this matching, this is opening in an x direction. It's a positive x squared. Positive x squared, negative x squared, positive x squared, negative x squared. It's either 7 or 9. The center appears to be at 0, 0. Since the center is at 0, 0, this is 0, 0. Here is A. B, notice we're counting by 2, so it looks like this is maybe down 3. So the myvoy appears to be -3. And here it is. That one's opening right and left as well, so I believe this one's B. C opens up and down. It looks like the center is over 2, up 2. Myvox, myvoy, 2 and 2. Also, it's opening up and down, so it should start with positive y squared. So this one's C. I guess this one must be D, but let's confirm. Center 0, 0 opens up and down positive y squared. Okay. Let's take a look. Let's draw these carefully. I think I've seen people do this without diagrams. My first thought is they probably just got it from somebody else's work or the back of the book, but then they've talked me through it. But I think for most people, probably a good idea to draw this carefully. Right 3, left 3, up 0. We have a vertex here, a vertex there, which means our hyperbola is opening right and left. It's positive x squared. That's one of the things we need to know is direction. We need to know the center. Well, the center is clearly 0, 0 on this problem. And the foci, can't spell foci without C, are right and left 6. So we know the direction. We know the center. We know A is 3, distance to the vertex. We don't know B, but we know C is 6, distance to the foci. So if it opens right and left, it's x, positive x squared, so it's x minus 0 squared on minus y minus 0 squared on equals 1. X squared is on A squared 9. Y squared is on B squared. We need to find B, but there's a Pythagorean relationship. C squared is A squared plus B squared, or 36 equals 9 plus B squared. B squared, therefore, is 27. And we could solve for B. And if we needed to come up with a good graph of this, you'll see later that we would need to know what B is, but I really only want to know what B squared is. This is A squared, this is B squared, and we've got it. Okay, 14, very, very similar, probably a good time to try one. A little bit more going on with it, but feel free to pause this and try it. I'm going to graph this carefully, right and up, right and down. Let's see, right 2, up 1, 2, 3, there's a vertex, down 1, 2, 3, there's a vertex, here's the center, we must look like this. wraps around the foci. The foci are at 2, 5, and 2, negative 5. So things I know it opens up and down. I need to know that. It's going to be a positive y squared hyperbola. I need to know the center. The center is 2, 0, just the midpoint of those. I need to know A. The distance is 3 to the vertex. I need to know B, but I don't know it yet. Sometimes I'd like to know C, and I do know C. That's 3, 4, 5. I need to know C if I don't know A or B. Okay. So we've got, it opens up or down. That's y minus y coordinates. So y squared, y minus 0 squared on A squared minus x minus 2 squared on B squared equals 1. But C squared equals A squared plus B squared. B squared is 16. B is 4, but truthfully, I only need to know that. All right, 19. Here's that passes through problem. Later on, they give us a point that it passes through. I fully expect to put 5 in for x and 4 in for y at some point. Let's see what we've got here. Left and up, right and up. So we've got a vertex, the center must be here. So things I know, it opens right and left. The center is 0, 1. A is 2. B I don't know. C I don't know yet. Okay. So what do I know? It opens right and left. It's an x. So right now it's x minus 0 squared, excuse me, on A squared 4 minus y minus 1 squared on, I don't know, 1. But I can't find B if I don't know C. That's what I've been doing in the past, using that focus to find it. So I'm going to have to go with this. I'm going to put B squared here, and now I'm going to do my substitution. So 5 squared x on 4 minus 4 minus 1, 3 squared on B squared equals 1. 4 minus 1, 3 squared, I get 25 on 4 minus 9 on B squared equals 1, and I'm going to multiply everything by 4B squared. And when I do that, the 4's cancel. I get 25B squared minus, distributing the B squares cancel, I get 9 equals 4B squared. Nothing cancels. Let's see, that's 21B squared equals 9. That's B squared equals 9 on 21, or 3 on 7. So my final equation is x squared on 4 minus quantity y minus 1 squared on 3/7 equals 1. And there you have that problem. Okay, let's take a look at, are we ready for page 2 here? Seems to me I'm missing a page, and that's going to be troubling to me. Oh, nope, that was the second page, third page. Shoo, I was nervous there. I had the screen freeze up on me a couple times. I don't want to lose this one and have to do it again. Here we go. Find the center, the vertices, the foci, the asymptotes of the hyperbola, and sketch the graph. Okay, things I know just by looking at this. It opens this way. It's a positive x squared. I know the center is 0, 0. It's x minus 0, y minus 0. I know that A is the positive. It's not necessarily the biggest, it's the one with the positive. A is square root of 9, 3. B is square root of 1, 1. C, if I need it, c squared equals a squared plus b squared. C is square root of 10. Suspect I'll need those when I talk about the foci. So center 0, 0. I'm going to move right and left 3. I'm going to move up and down 1. So I need some good room for right and left. 1, 2, 3. 1, 2, 3. Up 1, down 1. And now you're going to get to see where our ellipse graphing comes in really handy here. If I was going to graph this ellipse, I would say let's go over 3, right 3, left 3, underneath y and up down variable, up 1, down 1, and we would go ahead and draw our ellipse. Now what we're going to do instead is draw a box through those points, and through the corners and through the center we build our asymptotes. So either my hyperbola opens up here, down here, or over, but since it's positive x squared, it opens right and left. So I'm going to go right to this vertex, build a curve that gets sucked into the asymptote. It does not pull away from the asymptote. It virtually becomes a straight line on the asymptote. Don't let it get pulled away from the asymptote. If it did that, it might be more like a parabola. So there it is. We've got vertices so far, so let's check them off. We've got the center. Our vertices are to the right 3, to the left 3. So that's plus or minus 3. They're up 0. Our foci are right and left square root of 10. So square root of 10 is just a little bit more than 3. So the foci are located at plus or minus square root of 10, 0. And the asymptotes, well, the asymptotes are just lines. And what do we need to come up with an equation of a line? We need a point, and we need a slope. Well, both asymptotes go through 0, 0. How convenient for this problem. And the slope, well, from this point to this corner point, we went up 1, we went up b, we went over 3, we went over a, but I don't need to know the ab, I just need to know the slope, up 1 over 3. So the slope is 1/3. How about this one? Down 1 over 3. So here's our equation, y minus the y coordinate equals slope plus or minus 1/3 times x minus the x coordinate. Of course, those zeros are extraneous, just for show, but they're certainly going to become a player in the next problem. So in this case, I would simplify, but otherwise I wouldn't. I'd just leave it in that form. And there we have it. Okay, let's take a look at 30. 30 is a mess just because we have these tiny little micro moves here. This is a y squared, therefore it opens up, down. We've got a is the square root of 1/9. It's not the bigger of them. Notice it's the positive one. This is a squared, so a is just 1/3. We're going to move 1/3 right and left from the center. B is 1/2. C, we're going to need it, so c squared equals 1/9 plus 1/14. Let's see, that is on 36 times 4 on 4 times 9 on 9. C is 13 on 36. C squared is. So C is square root of 13 on 6. Oh, definitely not pretty at all. But we've got everything we need now to come up with a graph. So here we go. Let's see, center, -3, negative 4. My vox, my voy. So I need to go left 3, down 4, and I'm going to make a big graph. Left 3, because I'm making tiny little moves. Left 3, down 4, and there is our center. From there, I'm going to go up and down 1/3. Tiny little moves here. Up and down 1/3. I'm going to go right and left 1/2. Build our rectangle. Build our asymptotes. Sketch an up and down. Right here's the vertex. Right here's the other vertex. Get it to the asymptotes. Don't pull away from them. So far, so good. So let's talk about the vertices. Where are the vertices located at? To get to this vertex, I went left 3, and then I went 3 and up. I went down 4, but up 1/3. Negative 3 2/3. And then I went negative 3, I went down 4 and another 1/3, negative 4 and 1/3. The foci are up and down square root of 13 on 6. I don't know, square root of 13 is closing in on 4, about 2/3. Still just not much of a move up at all, not much of a move down at all. So the foci are actually easier to label. To get to those, we went to the left 3, we went down 4, and then from there we went up and down, plus and minus square root of 13 on 6. And elusive asymptotes, which should not be bad. I need a point. Well, the point they pass through, they both pass through, is negative 3, negative 4. I need a slope. Well, this slope, to get here, I had a rise of 1/3, up 1/3, that's my y change. My x change, I run 1/2, it's up 1/3 over 1/2, which is 1/3 times 2 on 1, 2/3. So our equation is y minus the y coordinate equals slope plus or minus 2/3 times x minus the x coordinate, because of course these lines, this is down just as far, over just as far, thus the plus or minus. Okay, hope that made sense. 38. Oh, now we got to do some work here. Now we got to complete the square. A little bit more dangerous. 3 times y squared plus 2y, leave a blank, minus 5 times x squared. Here's the most common error, is the very next thing we would write. Factored out a negative 5, so plus 12x equals 192. All right, so we need half of 2, 1, squared 1, plus 1, but I just changed the value. We should be getting pretty solid at this. Half of 12, 6, plus 36, change the value. What did I really do here? I really added 3, and I'm working without calculator here. I really subtracted 150 and 30. I really subtracted 180, so I get 3 times y plus 1 squared minus 5 times x plus 6 squared equals, this would be 12 plus 3, 15, exactly what I would hope it would be. That works great with the 3 and the negative 5. So, driven by the 15, I want to turn that into 1. I'm going to divide 15, divide 15, divide 15, both sides by 15. y plus 1 squared on 5 minus x plus 6 squared on 3 equals 1. And now I've got what I need. This opens up, down. The center is -6, -1, my vox, my voy. A is square root of 5, B is square root of 3, C squared is A squared 5 plus B squared 3, 8, C is 2 square root of 2, and we got all the heavy lifting done. Now it's just the fun part, we get to draw the graph. So I need to be left 6, down 1, and I don't have to move too far from there. So there's our center, which we already have. From there, I'm going to go up and down square root of 5. That's a little bit more than 2. Up 1, 2, a little bit more than 2. Down 1, 2, a little bit more than 2. I'm going to go right and left, square root of 3, about 1.7. So over 1, about 7. Over 1, about 7. I'm going to draw my rectangle through those points. Come up with my asymptotes. Oh boy, my graph is going to be invading my work up here, but it is what it is. And this is y squared. It opens up and down. So right here, right there. Giving me, let's see, I've got my center, boxing myself in. I need some room for that problem too. My vertices, to get there I went left 6, and then I went down 1, and then I went up and down square root of 5. To get to the foci, I went left 6, I went down 1, I went up and down square root of 8, which is just about 3. 1, 2, 3. 1, 2, 3 up in here. So that's plus or minus 2 square root of 2. And for the asymptotes, I need a point. By the way, definitely worth noting this. Take a look up here at 30. Look at this. Y plus 4, y plus 4, x plus 3, x plus 3. Think about that. That ought to make some sense. So this is going to be y plus 1 equals something times, try that again, y plus 1 equals something times x plus 6. Just need my slope, and my slope is rise over run. My rise is square root of 5. My run is square root of 3. That is square root of 15 on 3. Plus or minus square root of 15 on 3. There's our asymptotes, vertices, foci, center, and we got it. There's a lot going on there, admittedly. Okay. Now, when they give us the asymptotes, that's probably worst case scenario. So let's take a look at number 42. In fact, worst case scenario is going to be 50, where they give us the foci and the asymptotes. Yikes. So 0, 3, so that's up and down 3. 1, 2, 3, 1, 2, 3. We look like this. I've got direction. The center is 0, 0. We're to find the standard equation. So here's what I know. It is a y squared minus an x squared, center 0, 0. I know that. Because the distance to the vertex is 3, a is 3, a squared is 9. I've got all of that. The asymptotes, watch this. As I build that rectangle, and it's kind of arbitrary how far out right and left I've gone for this. but the asymptotes are plus or minus 3x. So our slope is up 3 over 1. But our slope is a being 3 over b. So that is a being 3 over b. Cross multiply, 3b equals 3. Therefore, b is 1. And we've got it. A little bit sneaky there. It didn't have to happen where these 3's match. This could have been a 4 on b, and then we cross multiply and we get 3b equals 4, b equals 4/3. This was just a really nice problem. 50 definitely presents some more challenge for us. So of all of these we've done, I'm not saying any of them are easier, but I will definitely say 50, put a star on it. If there's an honors level problem in this section, this is it. Foci, right and up, right and further up. That's a focus, not a vertex. 2, 3, 4, 5, 6. That's a focus. So our curve looks something like this. Now it may be closer than that, but it's definitely an up-down. The center is halfway between these, halfway between 1 and 1, 1. Halfway between 2 and 6, 4. It opens up and down, so it's y minus 4 squared on minus x minus 1 squared on equals 1. And then they give us our asymptotes. Now, because they gave us the foci, we got center. A we don't know, B we don't know yet, but C, at least C we know. It's my least favorite to know. And then they give us the asymptotes. And the asymptotes have a slope of 2. So from our center, that's up and over. We build that box right here. And I don't know, again, I'm not trying to claim that that these points are at 3. We don't know how low this half of the hyperbola dips. We don't know how high this one rises to. So what we do know is that c squared equals a squared plus b squared. And what we do know is that this rise from this center point to here would be a. Our run would be b. Our rise is to the vertex. So a on b has to equal a slope of 2 or negative 2. And that means that a may be replaced by 2b. Cross multiply. So let's see, c squared 4 equals 2b squared plus b squared. Replaced it. That's 4 equals 4b squared plus b squared. 5b squared equals 4. B squared equals 4/5. B squared equals 4/5. Therefore, b equals 2 on square root of 5. So a equals 2 times 2 on square root of 5. So a is 4 on square root of 5. A squared goes here. A squared is 16 on 5. Yikes, there's a lot going on that problem. So nice little substitution there. Fortunately had more room here than I thought we might need for it. I hope that's helpful. You're definitely going to get some practice on those. If you're 2020 e-learners, for you guys that aren't in class to get your questions answered, I'll have videos up. And in fact, that video's will be up by the end of today, which is 3/27. So my plan is to have that video up. The beginning of it is up already. So for those of you who are really diligent and working ahead, great for you. And again, special thanks to the gal who contacted me and set me straight on this one. Very observant and very helpful to all. Let me know what I can help you with, and stay safe.